Running LLMs efficiently often require an optimized, lightweight, and a scalable solution. That is exactly where Ollama comes in, an open source tool designed to simplify LLMs execution on local machine with API-based integration. Hello everyone, I'm Sanskriti Harmok, a developer relations at Vultr, and today I'm excited to walk you through how you can run LLMs using Ollama on Vultr Cloud GPUs. In this tech talk, we'll first explore what Ollama is and how it simplifies local model execution. Next, we'll discuss the supported models, including DeepSeek R1, Qwen 2.5, Mistral, Llama 3, and Code Llama. After that, we'll dive into how Ollama integrates with cloud GPUs for enhanced inference performance. Finally, we'll go through a step by step demo showing how to deploy and run LLMs on Vultr high performance infrastructure. So, without any further ado, let's get right into the video. To start, let's talk about Ollama and why it's an ideal choice for running large language models. Ollama is an open source lightweight tool designed to run LLMs locally without requiring an active internet connection. Unlike cloud based APIs that rely on external server, Ollama gives users a full control over their models, data privacy, and performance optimization. It also provides a RESTful API for managing models, making it easier to integrate into applications. On top of all of this, Ollama is also cross platform compatible, meaning it runs on Linux, Windows, and macOS, making it a versatile choice for developers working across different environments. Ollama supports a variety of multi-model LLMs, ensuring flexibility for different use cases. It can handle GPT-generated unified format along with MLX model formats, making it compatible with a range of AI models. Some of the notable models that work seamlessly with Ollama include DeepSeek R1, which is a powerful open source model optimized for reasoning and code generation. Qwen 2.5 Coder is a model designed specifically for software development and code completion tasks. Mistral, on the other hand, is a high performance transformer based model optimized for natural language processing tasks. Llama 3 is the latest evolution in Llama model series, which is designed for enhanced text understanding, whereas Code Llama is a model tailored for performing coding related tasks, helping developers with AI assisted programming. This versatility allows developers to experiment with different AI models while keeping cost under control by either running them locally or on cloud based infrastructure. Let's quickly go over the key advantages of running Ollama on Vultr Cloud GPU. Ollama provides a simple RESTful API for integrating AI capabilities into applications seamlessly. Using Ollama's repository, developers can pull models and start working without complex setup. Ollama even allows users to fine tune and modify models based on specific use cases, making AI more adaptable. Running models on Vultr high performance GPU ensure faster response time, making it ideal for real time AI applications. By leveraging Ollama with Vultr's scalable cloud GPU infrastructure, developers can efficiently deploy and run AI models without worrying about hardware limitations. Now that we have covered how Ollama simplifies running LLMs and how Vultr Cloud GPU enhances inference performance, it's time that we finally see it in action. Next up, we have a demonstration by Humphrey where we'll walk through the entire setup process of deploying a Vultr Cloud GPU instance and running large language model using Ollama. In this demo, we will deploy a Vultr Cloud GPU server, install Ollama on Ubuntu, pull a model from Ollama repository, run the model and interact with it real time, list all the available models to explore LLM options, and also discover more models for various AI applications. This hands on session will give you a clear step by step guide on how to use Ollama and Vultr Cloud GPU to run and scale LLMs efficiently. So, Without any further ado, I will hand over this stage to Humphrey to take us through the demo session.
So right within the Vultr customer portal, I already have a Vultr Cloud GPU instance that is already deployed on my account. To get right into deploying Ollama on this particular instance right here, I have an SSH session to it, and you can see that my hostname is Ollama host, which matches my Vultr customer portal specification right here. So right on the Ollama site, if we visit it with ollama.com, you can see that we have this simple download button right here. So if we are to click it right here and see the result, you can see that our operating system is Linux, which is auto-detected. And there is a simple one-line command right here we can copy to install Ollama. For this case, let's keep up with Linux, copy this command to the clipboard, and if we navigate back to the SSH station and paste it right here, now let's just monitor this model process and ensure that Ollama is successfully installed on this Vultr Cloud GPU server. And now that it has reached the 100% mark, you can see that Ollama creates a new user called Ollama user and some custom groups and an Ollama system MD service that is actually used to control Ollama on Linux. It has also detected that we have an NVIDIA GPU on this particular server, which is quite great and will enable us to actually run multiple types of models on this particular Vultr Cloud GPU server. So to get started with Ollama, let's first off verify the service that indeed it does exist. So let's just check the service status by running sudo service Ollama. So you can see in this particular output, the service status is active and running. And now let's just run the Ollama command by running Ollama just to see if we have access to it. You can see that it has some default help commands you can actually use to interact with Ollama on this workstation. So let's just go ahead and pull our first model and download it right on this workstation so that we can actually run it. If we just navigate back into the Ollama side here and just click models this time around to access the models repository, you can see that Ollama has some of the most popular models right here, which include Gamma 3, QWQ, DeepSeek R1, Llama 3.3, FIFO. So for this case, let's just get some of the most common models right here, and let's just pull DeepSeek R1 and let's just choose the 7B version. And notice right here we have a simple run command for DeepSeek R1, and if we copy it, go back into our terminal session and paste it in here. So what this will do is that it will download the DeepSeek R1 model files on this server. After that, we shall be able to use DeepSeek R1 on this particular server. So once all is complete, this model is already downloaded as soon as you actually execute the run command. And now in our particular output right here, you can see that we have downloaded the DeepSeek R1 model. We can successfully now get to use this model. As you can see that it says send a message. So right in here, let's just enter a simple prompt, something like, how are you today? You can see that it gives us a result in a much faster way. And right in this output, you can see that the model has served us a response and it says, thank you, I'm just a computer program. So meaning it cannot really react to personal questions, something like, how are you, which is more like a human-like prompt. So let's just close this and let's just use Ollama list to see all models that are available on this server. You can see that we only have DeepSeek R1. So for testing purposes, let's just go back to the Ollama page right here. Let's click models again. And this time around, let's pull a very big model like Llama 3.3 with the 7 billion parameters. So let's just copy the name this time around without running it directly. And let's just use the Ollama pull command, paste the model name, and verify that indeed we can download the Llama 3.3 model on this particular server. This will enable us to actually have at least multiple models we can use on this particular server. So now, as you can see in this particular output, we have also pulled the Llama 3.3 model on this particular server. So if we run the Ollama list command again, you can see that now we have Llama 3.3 and we have DeepSeek R1 models available on this server. So we can use these models at any time by simply running Ollama run and specifying the model name. For instance, let's just run the Llama 3.3 model, which is the latest we just added here. So let's just wait for the prompt to open up. For instance, let me just tell it to write a simple HTML application. And if we click enter, you can see that Llama 3 is quite faster than the DeepSeek R1 model that we did run. So now we can successfully use Ollama on this workstation. However, we are using a Vultr Cloud GPU server, and as noted earlier, the major advantage of you actually deploying Ollama in the cloud is to ensure that you have enough resources to run these models on your workstation. So to access Ollama on your workstation, you simply send an API request to this Ollama server, which in return invokes this particular model that is available on the server and grants you the desired results depending on your needs. So let's clear up this terminal a little bit, and let's just query for the Ollama service status again. You can see that it's running, but this time around, let's modify the service file so that we can actually add some variables we need to ensure that we can convert this Ollama host into a remote Ollama server. So let's just use the sudo nano flag and paste the service name. As you can see, it's ollama.service. And if we enter in here, let's just go right into the service section right here and add a new variable we'd like Ollama to run with. Let's just paste this in. So this particular variable is Ollama host. So in this case, let's specify 0.0.0, which will allow Ollama to listen for connection requests on all network interfaces attached to this server. So let's just change this default Ollama port, which is by default 11434. In production environment, you may need to change this to something like 8080, which allows you to actually customize Ollama and use reverse proxies as you may need. So let's just save this. And let's go ahead and restart the systemctl daemon in order to apply the service changes. Let's also restart the Ollama service. And now we have performed some key steps. However, there is a downside to this. If we clear up the terminal a little bit and just run Ollama list, you can see that we have this simple error right here. Actually solve an error like this, let's just export a new variable in order to make sure that Ollama can actually get these changes. And let's just specify the port that we are actually using. We press enter and run Ollama list again. You can see that this time around, we have a result. So now that we can safely access Ollama on this particular server, let's also use curl to verify that indeed we can access the port. And you can see we have this prompt, which is Ollama is running. However, all requests are local. Any other request to this server will actually be dropped. So let's just allow port 8080 through the firewall, and let's restart UFW to apply this change. If we just verify the UFW table now, you can see that we have a new rule that we've added on top of our default SSH rule. So this rule is 8080, so this will allow us to actually access this server from any host. So this will allow you to run Ollama on your mobile device or any other workstation that you could be presently using. For instance, I am using an Ubuntu local workstation, and I have a simple terminal right here. So what we're going to do is that we're going to send a remote request to the Ollama server and make sure that we can actually receive some model results. So to do that, let's just define curl first and foremost, and then I'll paste in these values right here. So these values are custom, and you can see that as per our graphic, we're accessing the API generate endpoint. So let's just find the IP address of our server that we're going to use in here. So if I just run IPA on this remote session and just copy the remote IP of this Vultr Cloud GPU server, go back into the terminal session and paste it right here. And now let's just come right into the model space right here, and let's use the Llama 3.3 model that we installed as the last model on this server, and just paste in my custom prompt, which is write a very short poem for my TikTok demo viewers and sign out with a greetings from Vultr message. So let me press enter, and let's just keep this model process just a little bit of time. If you like this process to be faster, first you will need to initialize this model by sending this model request without any prompt. But Llama 3 is quite faster, and you can see that we have an API response right here, and you can see it says, "Thanks for watching everyone. May your tech journeys be smooth and bright. And until next time, good night. Greetings from Vultr." So just like that, we have deployed Ollama, and I'd like to thank you for watching everyone. May your tech journey be smooth and bright. And once again, greetings from Vultr, and we hope that you did enjoy this demo. Hope you can deploy Ollama on your Vultr Cloud GPU instance.
To wrap things up, we have seen how Ollama simplifies running large language models locally and in cloud. By combining the open source flexibility and GPU acceleration on Vultr, developers can now build efficient and scalable AI powered application without relying on external APIs. In order to try it out, you can spin up a Vultr GPU instance today and start running your LLMs with Ollama in just a few steps. Thank you so much for sticking till the end and watching this tech talk. We hope that this walkthrough helped you understand how Ollama and Vultr Cloud GPU can work together to power your AI workloads. In case of any question, feel free to reach out to us.